So welcome, everybody, and thank you for joining this talk. My name is Roberto, and I'm a software engineer in the ARM ecosystem. I know this is the last talk of the day, so I really appreciate that you have come and joined us. So what if I tell you that just by ticking a box in Unity, you can improve the performance of your game and make your battery last longer? What do you think about that? Will be good to have that, yeah? But it is possible right now, because Unity 5.6 has integrated Vulkan, and Vulkan is another graphics API your game can run on. So today, I will talk about the benefits Vulkan brings to developers in general, and also the benefits the benefits of Vulkan when running on ARM CPUs and GPUs. I will also share with you some very interesting results of power measurements when running Vulkan compared with OpenGL ES using the Skyfall Reloaded game developed by Infinite Studios. Any new graphics API required of tools to allow developers improve their game. So today, I will show you how easy it is to use Mali Graphics Debugger, MGD, to debug your game, your Unity game, and I will do a live demo. So you know that the live demo is always a little tricky. Anything can happen there, so finger crossed, everything will be fine. And finally, I will do some wrap-up. So let's start talking about the benefits of Vulkan. Just a year ago, Kronos released the Vulkan 1.0 specifications, and the Kronos members started to release their first drivers. And today, just a year after that, today we are talking about Vulkan integration in Unity. And this is great. With this, Unity shows its support not only to Vulkan, but also to Unity developers that expect the best from Unity. But why Vulkan is so important? Why Vulkan is relevant for us? The point is that we've seen during the last years that OpenGL and OpenGL ES have completed their life cycle, and that it is impossible to evolve further on top of an API that carries so much inherited weight after serving the industry over 25 years. Additionally, Vulkan, there has been a lot of development in the GPU hardware. GPUs are becoming highly programmable and compute capable. The mobile platform is becoming more relevant. Memory is becoming unified, and processors are becoming multi-core. So Vulkan is, above all, stake for the GPU future. I will briefly go through two of the most important Vulkan features for graphics: multithreading and multipath. So let's talk about multithreading. Nowadays, even mid-range phones come with 4 cores, but traditional graphics API weren't designed for multi-thread use. The traditional graphics API, they had a lot of overhead on the CPU to manage draw calls, resulting in the CPU is becoming a bottleneck, especially on mobile devices. But Vulkan has been created from the ground up to be multi-threaded. In Vulkan, the driver has been released from responsibilities that are now in the hands of the application. It results in the driver to be highly simplified. As a result, the driver has been highly simplified. For example, the multi-threading responsibility has been moved up to the application level. So now it's up to us, developers, to make an efficient and correct use of the multi-threading feature. In Vulkan, the lower CPU overhead due to driver simplifications helps reducing the power consumption and makes the battery last longer. So thanks to this, we got lower CPU load and less energy consumption. But in this, the multi-threading plays a key role by allowing the CPU to get a sleep faster, since it can spread the work out to multiple cores. Additionally, ARM processors are able to schedule and migrate tasks between little and big cores according to the load, achieving this way an optimal energy balance. Let's have a look now to the multipath rendering feature. This feature is conceptually very similar to pixel local storage introduced by ARM in 2014. The beauty of the multipath is that you declare ahead of time everything. So you can have multiple subpasses. You can define different output for each subpass, and you can chain them together. It means for the current subpass, you can have as an input the output of the previous subpass. Multipath is especially performant on tiled GPUs, such as ARM Mali GPUs. The point is that multipath allows the driver to perform additional optimization when each pixel rendered in a subpass accesses the result of the previous subpass at the same pixel location. In this way, all the data remain in the fast on-chip memory. So we got a reduction in the data traffic with the main memory. It means less bandwidth use, and ultimately, less power consumption, and that makes also the battery last longer. The thread rendering is a very special, an excellent use case for multipath, as we can define different subpasses for preset, desktop pass, debuffer, light accumulation, or port processing. In this slide, I'm showing some screenshots from the Lofoten demo based on a game engine developed in-house to test Vulkan execution on ARM CPUs and GPUs. In this demo, we've got more than 100 dynamic lights with shadow maps. And the use of the multipath, thanks to the multipath, we can achieve an effective thread rendering in this case. And also, thanks to multi-threading, we are able to reduce up to 10 times the load on the CPU. This is just to show you the benefits we can get straightforward from Vulkan just because we are using it as our graphics API. So now I would like to share with you the experience from Infinite Dreams when optimizing their mobile game Skyfall Reloaded using Vulkan. We collaborated with them in power measurement of the mobile game when using Vulkan and OpenGL ES, and we compared the power consumption in both cases. So what is Skyfall Reloaded? Are you familiar with that game? So Skyfall Reloaded is a modern shotgun experience. It features an intense action. It has very rich graphics. But instead of talking about it, I will show you a short trailer.
Nice to see you again. You miss me. How nice. That thing gives me the creeps. Destroy them.
So as you could see, I mean, there's a lot of things happening in the screen, a lot of graphic effects, and very intensive action. But it wasn't easy for Infinite Studio, because at the beginning, they got problems in achieving a constant 60 FPS along the whole game. The problem was they thought at the beginning that it was a fill rate problem that you can solve by lowering the screen resolution of your game. It means rendering less pixels. But at the end, they found that the fill rate wasn't the bottleneck. So the real bottleneck was in the huge amount of draw code they were using every frame, up to 1,000, that can impact your game performance even in a high-end phones. So the CPU, the problem was that the CPU was spending a lot of time preparing the draw code to send to the GPU. So at this point, they knew that the draw code were expensive, that the OpenGL ES driver was not optimal, and they knew that Vulkan was available for the first time as a new graphics API in Unity. So there is, to make use of Unity, we don't need to do anything. The hard job has been already done by the Unity team. So Vulkan is just another graphic API together with OpenGL ES, I mean for mobile, for Android, together with OpenGL ES 2.0 and 3.0. So now we got Vulkan in that list. So they decided to try and Vulkan, because it's just out of the box when using Vulkan and building our game. And what they did first, they prepared a kind of synthetic benchmark with a part of the game where OpenGL ES struggled to achieve 60 FPS steadily. So in these graphics, we can see the comparison of OpenGL ES and Vulkan during the execution of that benchmark. And you can see that Vulkan, as an average, is 50% faster than OpenGL ES. And in some cases, that difference is up to 21%. But they didn't stop here. They thought, OK, we are not pushing Vulkan really hard. Let's prepare another synthetic benchmark where we will, what they did was start adding more graphics effect to the scene, more complexity, in such a way that at some point even Vulkan struggled to achieve 60 FPS. And at that point, they compare that with OpenGL ES. And this is what they got. So we can see in this case that, as an average, Vulkan was 32% faster than OpenGL ES, and in some cases, the figure rised up to 82%. So it means that Vulkan brings to us some extra power that we can use to add more content, more particle, objects, animation, to make, allows us to make our graphics richer and make our game more appeal to players without keeping the FPS, without affecting the performance of the game. So I will show you now a short video that explains that.
This video showcases a side-by-side performance comparison of the Vulkan API versus the OpenGL ES API in Skyfall Reloaded, a Unity-based mobile game from Infinite Dreams. On the right-hand side, you can see the game using Vulkan, and on the left, using OpenGL ES. Both versions are running at 60 frames per second. At this frame rate, Vulkan can render 6 times more stars and twice as many bullets compared to the OpenGL ES version. With OpenGL ES, rendering the same amount of objects would cause the frame rate to drop considerably during busy scenes. As you can see, Vulkan allows developers to add more geometry to the screen in comparison to OpenGL ES at the same frame rate.
But Vulkan can help us in a different way. One of the problems Infinite Studio had at the beginning was that some users reported that the game was draining the battery faster than usual. So they got some problem related with the power consumption. As you know, the console-like quality games, they consume a lot of power because there is a lot of graphics going on the screen, a lot of draw calls. So they decide as well to to see if Vulkan can help on that. And this is what we got when comparing Vulkan execution with OpenGL ES exactly under the same conditions, with the same scene, same graphic complexity, and you can see that the power consumption in Vulkan is always less than the power consumption on when running on OpenGL ES. So as a result, we obtained that Vulkan was able to save up to 12% of power during the game execution. So the majority of this saving comes from the CPU, as I mentioned before. Thanks to that the driver in Vulkan is a lot more simpler. There is the load on the CPU is drastically reduced. So Vulkan, in this case, can help us to gain some extra minutes of playtime when our game is running on Vulkan. And this is something players, as you know, always will be happy to have. So in principle, just summarizing this part of the talk, Vulkan is great to use out of the box. It will improve automatically our FPS and or add some extra minutes of playtime. But if we want to make use of this extra power that Vulkan brings to us, we can make our graphics richer. We can improve the graphics quality of our game without hammering the performance. So now, as I mentioned at the beginning, I would like to show you the result of the collaboration with Unity, where we have integrated the Mali Graphics Debugger, our tool for graphic debugging, into Unity. Thanks to the collaboration with Unity, this process has been drastically simplified, and I will show you now how easy it is to work with the Mali Graphics Debugger in Unity. But for those of you who are not familiar with Mali Graphics Debugger, just a few words. Mali Graphics Debugger allows you, as any graphic debugger, to go through all the draw calls and see what is happening in our application with every API call. The Mali Graphics Debugger supports Android and Linux platforms, and you can download it for free from our website, developer.arm.com. So the steps you need to follow to build an application with full support for Mali Graphics Debugger, I will show you here. And after that, just in a minute, I will make a live demo. So first of all, you need to place the library provided by the MGD installer in that folder in your project, under the assets folder of your project. You then click the development build option before building your application, because that will allow Unity to package the library automatically into your APK. So you build your game, you install the APK on the device, and you launch then the Mali Graphics Debugger desktop application, and yeah, you're ready to go. It's just 3 steps. For OpenGL ES, the process is as simple as for Vulkan, and it's very similar. It's just we need to place the library in a different folder. So now I would like to show you a live demo how simple it is now to build applications in Unity with full support for Mali Graphics Debugger. I will just close this. I go Unity here. This is a demo we show in the previous Unite event, Ice Cave demo. It's a complex demo with a lot of things going on the ice cave. So I won't build here the application. the demo. I just wanted to show you that we got here the library in the path of our project. In that path, we then need to tick the development option when building our application. So I won't build it here because it can take some minutes. So we build our application, and then we install on the device. We've got the device connected to the laptop. And well, the next step is just to launch the MGD debugger, our desktop application. You can download for free from our website, mali.arm.com. We press here to detect the device connected over USB. We press this button to connect to the device. So we are connected. And now I will launch our application. We already immediately start receiving the traces from the Vulkan API. And I will just stop at some point. I will pause here. And then I will press this button here and this one to make a capture with full of all data that are used by the application in that frame. So we are receiving all the info from texture, buffers, everything. So I will show you now that we will be able to go step by step through the API calls and see what is happening on the different buffers and the different render passes. So we are already there. So we go to the very end. We click here. So in Vulkan, as you know, the QSubmit API call is the one that defines and sends the info to the GPU and define our frame. Here, as you can see, we got 3 render passes. The first one, those are the different draw calls. The first one is related with the rendering of the shadows of the dynamic object. We do that in the, so we render the shadows from the dynamic object. The second render pass, for example, render the reflections of the dynamic object in the central platform of the ice cave. You can see there how it's possible to see. Maybe it is too light. You can see in the that square how we are rendering the reflections, only just part of the scene. And finally, the last render pass, we can see here all the draw calls. Let me just go. So where we are rendering the whole ice cave, let me just go a little up, just to show you how we can step. So you can see how we start rendering different elements of the ice cave. We are rendering first, as any game engine, the opaque geometry, and at some point we will render the last opaque object is the skybox. At some point it will be rendered now. This one, you can see that at the end is the entrance of the cave, and we can see there the skybox. And we start at this point, we can see how we start rendering the semi-transparent object, which are particles, and there is a butterfly, the bloom effect. So using MGD, you can step by all the API calls, in this case of Vulkan, but you can do the same for OpenGL ES, of course. So I will close this MGD. And you can see that it asks me, oh, do you want to save all this? Because you can save all the traces and have this to look at it later or to compare with another session. I won't save it. I will also close Unity. And we'll go to back to our slides. So I would like now with this picture to summarize the Vulkan benefits. As you can see, the driver has been released from responsibilities that are now in the hands of the application, and the implication of this shift are really important, especially for mobile devices. Less CPU load, more usage of fast on-chip memory. It means less transfer of data to the main memory. That ultimately means less energy consumption and longer battery life. So the takeaway from the talk: first, add Vulkan to the list of the graphics API supported by your application. You will get for free, for having Vulkan, for running on Vulkan, you will improve your performance and you make your battery last longer with your game. And also upgrade, if you haven't done yet, upgrade to Unity 5.6. So I'm ready for questions, if any. Yep. Please.
Thank you. I would like to ask, with your debugger, can you connect to device also via the Wi-Fi and IP address, or you have to have plug-in USB cable?
No. I mean, right now, you need to have the connection over USB. But we are working on Wi-Fi connection as well.
Okay, thanks. And second question, does it support also if mobile device run on Intel processor like Skylake, or have to be ARM?
We support, I mean, this version that you can download for free from our website support only Mali GPUs. But with a license, you can support other GPUs for other vendors. With a special license, yeah, you can support, MGD support other GPUs.
Also, if it is a Linux Ubuntu, can it work?
Yeah, I haven't worked directly with Linux Ubuntu, but it's the MGD support Android and Linux, as far as but I haven't tried. But yeah, it's support Linux Ubuntu. Definitely.
Okay, thank you.
Yep. Any other questions?
Thank you for your speech. Could you please tell what is the minimum requirement of hardware? Exactly, GPU, Mali GPU.
Yeah, the point, I mean, if you look how many devices are now supporting Vulkan, there are not much, because Vulkan is just, last year was released the specification, and as I mentioned, just a year ago, the Kronos members started to release the drivers. Right now, you can run Vulkan on the S8. There are other few, as far as I know, a few phones from China that support Vulkan. But we can definitely think that in the coming months, there are more and more devices with Vulkan support. But Vulkan is not supported in previous phones. I mean, you won't find Vulkan support in phones that has been released previously to the Vulkan release.
Okay, and the second question is, are there any requirements for assets production pipeline to use more efficiently?
Not really.
Vulkan?
No, I mean, not really. This is completely transparent for the user. It is the same, I mean, in connection with the asset preparation, the same process you will follow for OpenGL ES 2 or 3.
Okay, thanks a lot.
Thank you. Yeah, that is.
Thanks for the talk. I wanted to know if I want to pass to Vulkan on one of my projects, would I have to rewrite some of my custom shaders, or what would the...
Not at all. So it was, I had this kind of problems when Vulkan was just start working on Unity because I was following it with interest. But right now, you can switch to Vulkan and everything. You don't need to change anything in your shader. That is the real advantage because all the hard job, and it is really hard, because Vulkan, as you know, is very, it's a more lower level API that allows a lower level control of your GPU. But all the hard job have been done by Unity, and it's completely transparent. No changes in your shader are needed at all. Just add Vulkan to the list of the graphics API supported by your game.
Thank you very much.
Yeah.
Hello, thank you for the talk. I was wondering about the stability of Vulkan in Unity as it is right now. Like this other person, we have a project running right now, and of course, if it indeed performs better and its power consumption is better, the only worry that I have left is, are there any instability issue or risks that might apply?
I mean, as far as I know, and I have been testing it as well with different demos, and the last one that I show here is really complex. There are a lot of things happening on the screen, and I haven't had any problem at all. As I mentioned at the beginning, yes, at the beginning, but they have fixed. And we are working in collaboration with Unity to, from the very beginning to fix any bug in drivers or so on, because every time you start working with a new API, there are problems with the drivers. But the drivers has achieved really stability, and the main point here is that the driver has been so much simplified that the chances of bugs in the driver are reduced drastically, because the driver is really simple. This is one of the main advantages from Vulkan. Of course, part of the job has been passed to us. But in the case of high-level engines, graphic engine or game engine as Unity, they have taken care of all the complexity of the Vulkan implementation into the rendering pipeline, into Unity rendering pipeline. So we don't have to care about anything. Just strongly recommend just to have a go to Vulkan and check, especially, for example, if you got detect that your game is CPU bound because there are a lot of draw codes as an example, just give it a go to Vulkan, because just by selecting Vulkan you can improve the FPS, the performance of your game. In other cases you will need to make more deep study of what is happening in your game, but give it a try.
Okay, thank you.
Yeah, sure.
Is it already a viable option to have deferred rendering on mobile using Vulkan, or is that still a little bit more in the future?
No, it's something that you can do right now. I mean, it's working, and this is an S8. Yeah. Even it is not the latest Samsung device. It is not our latest GPU, but it's running on our GPU. And it's rendering really nice with a nice performance. So it is something that is part of the daily life already in Unity. You don't need to wait for the future. It's really now. It's up to us now to use it, start using it.
This is also deferred rendered? The demo you're showing there?
No, this is not deferred rendering.
I mean, what's showing there on the telephone?
No, this is...
The ice cave?
Sorry, this picture?
Yeah.
This picture is taken from the
ice cave.
From this demo, the ice cave demo. No, the ice cave demo is not doing the deferred rendering, but as I mentioned, we got a game engine developing house, and with this engine we produced the Lofoten demo, and we were able to implement the deferred rendering really efficient in mobile devices that up to now has been really, I mean, it's not practical. Yep. We haven't got any deferred rendering on mobile, working on mobile, and we were able to do it. I will mention something that engine was was initially written for OpenGL ES, but it was completely rewritten for Vulkan, Because if you want to just add to your engine Vulkan on top of the existing implementation for OpenGL ES, you won't get all the potential for Vulkan. So yeah, you need to think in a little different way, in a Vulkan way, to make the most of it.
Okay,
But it's completely transparent. Okay. I mean, Unity has taken, has done all the hard job for us.
Okay, Unity is doing just that, right?
Yeah, exactly,
okay.
exactly.
Okay.
Everything is, it's transparent for us.
Yeah. Thank you.
Any other question? No? So if there is no more questions, so thank you very much for attending. I know that this was the last talk of the day, so thank you very much. I appreciate that.